Example 1a. Find the value of m given 5, m, 20 forms an arithmetic progression. Now, since these three terms form an AP, they're consecutive terms, there is a common difference between these three terms. In other words, m minus 5 will equal 20 minus m. So we can form an equation to that effect and then solve for m. So m minus 5 is equal to 20 minus m. Adding m to both sides and adding 5 to both sides, we have 2m equals 25. And then dividing both sides by 2, we have m is equal to 12.5. Now, there is an alternative solution, which is very similar to the first method, but it uses the fact that m is the average of 5 and 20, and it uses that fact explicitly. So Tn is equal to Tn minus 1 plus Tn plus 1, so they refer to the terms on either side of m, and then divide that by 2. M is equal to 5 plus 20 over 2, and therefore m is equal to 12.5. So the AP is 5, 12.5, and 20. Now let's have a look at an example involving a geometric progression. So part B, example 1b, find the value of b given 5b 20 forms a geometric progression. Now, since these three terms form a GP, there is a common ratio between these three terms. So in other words, b divided by 5 will equal 20 divided by b. So we can form an equation again to that effect. So b over 5 equals 20 over b. With cross multiplication, we get b squared is equal to 100. We take the square root of both sides. We get b is equal to plus or minus 10. So there's two values for b. So there's two GPs. So one case is b is negative 10. We have 5, negative 10, 20. Or if b is positive 10, 5, 10, and 20. Example 2. The third term of an arithmetic progression is 16 and the 12th term is 79. Find the 50th term. Let's write down what we know. We know that T3 is equal to 16. So when n equals 3, T3 is 16. We know that when n equals 12, T12 is equal to 79. So we want the value of T50, in other words, the value of the term when n equals 50. So we need to use the formula for the nth term of an AP. So Tn is equal to a plus n minus 1d. We're going to form two equations using that formula and then solve that simultaneously to find the values of a, the first term, and the common difference d. So using T3 equals 16 and forming our first equation, we have 16, so T3, 16 is equal to a plus n minus 1d. Now n is 3, so 3 minus 1 is 2. So the formula is 16 equals a plus 2d. Now using the fact that T12 is equal to 79, we can form another equation. So 79 is equal to a plus 11d. So again, n minus 1, 12 minus 1 is 11. So we have this second equation here. Now we need to solve simultaneously for a and d. And we can use the elimination method because we can easily eliminate a by subtraction. So equation 2 minus equation 1, we have 79 minus 16 is 63. A minus a is 0, of course, and 11d minus 2d is 9d. And dividing both sides by 9, we get d is equal to 7, so that's the common difference. Now using either of the two equations in the simultaneous equation, either equation 1 or 2, whichever is the more convenient, I'm just going to use equation 1, substituting in d equals 7 into equation 1, and then just rearranging the formula, we can determine the value of a. So from 1, 16 is equal to a plus 2 times 7. 16 is equal to a plus 14, hence a is equal to 2, so that's the first term of this AP. So to work out T50, we just use the nth term for an AP formula. So T50 is equal to 2 plus n minus 1, so 50 minus 1 is 49, multiplied by the common difference 7, and we get T50 is equal to 345. So therefore the 50th term is 345. Example 3. The fourth term of a geometric progression is negative 128 and the seventh term is 8,192. Find the first term, the common ratio, and the 100th term, leaving your answer in simplest index form. Let's start by writing down what we know. We know that T4 is equal to negative 128. We know that T7 is equal to 8,192. We need to find T100. But to find T100, the 100th term, we need to find A and R. So the first term and the common ratio. Now recall that the formula for the nth term of a geometric progression is Tn is equal to AR to the power of n minus 1. So we can use that to then form two equations which we can then solve simultaneously. So we know that T4 is equal to negative 128. So the equation we can form is negative 128 is equal to A multiplied by R to the power of n minus 1. Now n is 4 in this case, so 4 minus 1 is 3. So equation 1 is negative 128 equals AR to the power of 3. The second equation we can form is based around T7. 8,192 is equal to AR to the power of 6, of course, because it's 7 minus 1, n minus 1 equals 6. Now we can solve this simultaneously. We do that by taking equation 2 and dividing it by equation 1. So 8,192 divided by negative 128 is negative 64, and AR to the power of 6 divided by AR to the power of 3 is equal to R cubed. And then taking the cube root, of course, of both sides, so we have R is equal to the cube root of negative 64, and therefore R is equal to negative 4. So there's only one common ratio here, not two cases like in previous examples where you could have a positive R and a negative R. In this case, it's only a negative R. So we can use either equation 1 or 2 now to find the value of A. I've just chosen equation 1. Negative 128 equals A multiplied by negative 4 cubed. So we can use our value of R now that we've found, substitute it in here for R, and then solve for A. And we end up with A equals 2. Now we can find the 100th term. So let's again write down what we've just discovered. So we know the first term is 2. We know the common ratio is negative 4. We need to find T100. Using the formula for the nth term of a geometric progression, Tn is equal to A multiplied by R to the power of n minus 1. So T100 is equal to 2 multiplied by negative 4 to the power of 99. Now because this is an odd power, the negative sign can come out to the front. So that equals negative 2 multiplied by 2 squared. So I've got sort of two things here at once. I've also written the 4 as 2 squared because I can combine these two bases together. So using the power to a power rule, 2 squared to the power of 99 is 2 to the power of 198, and we're going to multiply that by negative 2. So combining all those together, so we have a common base here of 2. This equals negative 2 to the power of 199, and this corresponds to the 100th term of this geometric progression. Example 4. Find the first term greater than 1 million in the GP 3, 3 root 2, 6, and so on. So we're going to solve for n, given that Tn is greater than 1 million in the formula Tn equals AR to the power of n minus 1. So this is the formula for the nth term of a geometric progression, but we want to find the smallest n such that Tn is greater than 1 million. Now A is equal to 3, and the common ratio is square root of 2. So again, we're told this is a GP, so there's no need to prove this. But 3 root 2 divided by 3 is just root 2, so that's the common ratio. So the inequality becomes 3 outside of square root of 2 to the power of n minus 1 is greater than 1 million. And dividing both sides by 3, we have the square root of 2 to the power of n minus 1 is greater than 333,333 1/3. So now we take logs of both sides, and you can use any base, but I'm just going to use log base 10. I know in a previous example I used the natural log, so ln, but you can use log base 10. So log base 10 of square root of 2 to the power of n minus 1 is greater than log base 10 of 333,333 1/3. And we can use one of the log laws here, so log law number 3, to take out the n minus 1 and bring that out to the front. So n minus 1 multiplied by log base 10 of square root of 2 is greater than log base 10 of 333,333 1/3. And then dividing both sides by log base 10 of square root of 2, we can make n the subject of the inequality, and we end up with n greater than 37.69 ... So the next integer greater than this value is n equals 38. So that corresponds to the position of the term that's, the first term that's greater than a million. So that's going to be the 38th term. So we need to determine what that term is. So t38 is equal to 3 multiplied by the square root of 2 to the power of 37. That's n minus 1. And then just evaluating that, and I'm just going to round it to one decimal place, or we can keep it in exact form. It doesn't really matter. It just depends what the question's asking, of course. And we end up with 1,112,182.8, and that's correct to one decimal place.